November 23, 1943. Corporal James Sullivan stood beneath the nose of a P-38 Lightning at Nadzab Airfield in New Guinea, watching condensation drip from the gun ports, while his pilot, Lieutenant Robert Chen, climbed into the cockpit for what would likely be his last mission. Chen was 24 years old, 13 combat missions, 2 kills. The Japanese had sent 22 Mitsubishi A6M Zeros and 6 Ki 43 Oscars to intercept the morning fighter sweep over Wewak. Chen would be flying straight into the heart of them. Sullivan had been maintaining P-38 electrical systems for 11 months. He knew every wire, every relay, every connection point in the twin-boom fighter's complex gun system. The P-38 Lightning carried devastating firepower, 4 50-caliber Browning machine guns and 1 20mm Hispano cannon, all mounted in the nose. No engine synchronization needed, no worries about shooting through propeller arcs. Pure, concentrated firepower, aimed wherever the pilot pointed the aircraft. But the P-38 had one electrical problem that was getting American pilots killed every single week. The guns wouldn't fire together. The issue was in the firing circuit design. Each gun had its own solenoid trigger, activated by separate electrical pathways, running from the control stick through a distribution box mounted behind the instrument panel. The system was designed with safety in mind. If one gun jammed, the others would keep firing. If one circuit shorted, the pilot wouldn't lose all his weapons. Lockheed's engineers had built redundancy into every connection, but combat had exposed a fatal flaw in that careful design. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Under the stress of high-G maneuvering, rapid temperature changes, and the constant vibration of twin Allison engines running at war emergency power, the electrical contacts in the distribution box would develop microscopic gaps, not enough to fail completely, just enough to create a delay. When a pilot squeezed the trigger on his control stick, the electrical pulse would travel through the main circuit to the distribution box, then split into 5 separate paths, 1 for each weapon. In theory, all 5 solenoids should activate simultaneously. In practice, they fired in sequence. The delay between the first gun firing and the last gun firing was typically 0.27 seconds, less than a third of a second. In a ground test with the aircraft stationary, you'd never notice it. But in combat at 350 miles per hour, closing on a target at a combined speed of over 600 miles per hour, that fraction of a second meant the difference between a concentrated burst that destroyed an enemy fighter and a scattered spray that missed completely. Chen had experienced this problem on every single one of his 13 missions. His first kill came on his 8th mission, and only because he'd gotten within 75 feet of a zero before opening fire. That close, even the staggered firing pattern couldn't miss. His second kill happened when a damaged Oscar flew directly into his line of fire, already trailing smoke from an attack by his wingman. But Chen had lost count of how many times he'd lined up a perfect shot, squeezed the trigger, and watched his tracers walk across empty sky as the target maneuvered through the gaps in his fire. The guns fired. They just didn't fire together. And in a dogfight where your window of opportunity lasted maybe 2 seconds, you needed every bullet hitting the same spot at the same instant. The training manual said the solution was to get closer before firing. The gunnery instructors said pilots were opening fire at excessive range. The squadron intelligence officer said American pilots were overestimating their deflection angles. Sullivan knew better. The problem wasn't the pilots. It was the wiring. He'd first noticed it 3 months earlier while troubleshooting a gun jam on Lieutenant Mark Foster's aircraft. Foster had returned from a mission furious, insisting his guns were malfunctioning. He'd had a zero dead center in his gun sight at 200 yards, squeezed the trigger, saw his tracers curve around the target like water around a rock. Foster was certain something was wrong with his weapons alignment. Sullivan checked everything. Bore sighted all 5 guns, checked the harmonization, measured the convergence point. Everything was perfect. All 5 weapons pointed at exactly the same spot, 300 yards ahead of the aircraft. Then Sullivan did something most electricians never bothered with. He brought a stopwatch to the firing test. He had the armament crew load a 10-round belt into each gun, positioned himself where he could see all 5 muzzles, and had another mechanic activate the firing circuit from inside the cockpit. What he saw changed everything. The top left 50 caliber fired first. A fraction of a second later, the top right. Then the bottom 250s. Finally, maybe a quarter second after the first gun, the 20mm cannon. Sullivan ran the test 4 more times. Same sequence every time. The guns weren't firing simultaneously. They were firing in cascade. He traced the wiring back to the distribution box, pulled the access panel behind the instrument panel, and examined the relay system. The design made sense on paper. The electrical pulse from the trigger switch hit a main relay, which then sent power to 5 secondary relays, 1 for each weapon. But the secondary relays weren't identical. They had slightly different resistance values, slightly different coil impedances, close enough for the original specifications. But under combat conditions, with voltage fluctuations from the generator, temperature variations affecting the relay coils, and vibration causing state caving, intermittent contact resistance, those tiny differences created the firing sequence Sullivan had observed. He wrote up his findings in a maintenance report, submitted it to the squadron engineering officer, Captain Theodore Barnes. Barnes read it, looked at Sullivan for a long moment, and said the electrical system was within factory specifications. Lockheed had designed the circuit with those tolerances intentionally. Changing the relay configuration would require engineering approval from the manufacturer, and Lockheed was 7,000 miles away in Burbank, California. Besides, no field electrician had authorization to modify aircraft weapon systems. That required certification from the Army Air Force's Technical Service Command. So Sullivan watched Chen and 23 other pilots in his squadron fly missions with guns that fired out of sync, watched them come back frustrated and exhausted, heard them describe perfect shots that somehow missed, watched the squadron's kill ratio stay stubbornly low, while other P-38 units with better luck or better pilots racked up victories. 3 pilots Sullivan had worked with personally died in September. Lieutenant David Harrison went down over Finchhafen on September 14th. His wingman reported Harrison had a Zero lined up for a killing shot, fired, saw his tracers scatter, the Zero reversed and got on Harrison's tail. Harrison never made it home. Lieutenant Paul Schmidt died on September 22nd. Schmidt was experienced. 19 missions, 4 kills. He engaged 3 Oscars at 12,000 feet over Madang, got behind one, fired from close range. His combat camera footage showed the problem clearly. The first 50 caliber tracers appeared in frame, then the second, then the third and fourth. By the time all 4 50s were firing, the Oscar had rolled 15 degrees and was already accelerating out of the line of fire. The 20mm rounds never even got close. One of the other Oscars shot, Schmidt downed 30 seconds later. Lieutenant Thomas Riley survived his shoot-down on October 6th, but barely. Riley got separated from his flight during a furball over Wewak, found himself with 2 Zeros on his tail and 1 head-on. He went for the head-on shot. Squeezed the trigger at 600 yards closure rate, probably 1,200 miles per hour. His guns fired, but the Zero fired first and more accurately because the Japanese pilot's weapons were mechanically synchronized, firing simultaneously. The Zero's rounds walked through Riley's right engine. Riley made it back to base on one engine, crash-landed on the runway, and spent 3 weeks in the hospital. When Sullivan visited him, Riley described the engagement in detail. He'd had the Zero perfectly centered in his gun sight, squeezed the trigger early to account for the closure rate, watched his tracers appear but never converge into a solid stream of fire. He saw individual rounds passing on either side of the tracer, Zero's fuselage. The Japanese pilot must have seen the same thing. Had time to adjust his aim and take the shot that nearly killed Riley. Riley told Sullivan he'd done everything right. Range, deflection, trigger control. But the airplane hadn't delivered the firepower when he needed it. Sullivan knew Riley was right. and he knew the problem would keep killing American pilots until someone fixed it. The worst part wasn't the pilots who died. It was the ones who came back alive but shaken, doubting themselves, second-guessing their gunnery skills, wondering if they'd squeezed the trigger too early or too late, aimed too high or too low. Sullivan watched them in the ready room, replaying their missions in their heads, trying to figure out what they'd done wrong. But they hadn't done anything wrong. The airplane had failed them. By mid-November, Sullivan had watched 19 pilots from his squadron die or get shot down. Some he'd known well, worked with daily, shared meals within the mess tent. Others he'd only met briefly during pre-flight inspections, but he'd signed off the electrical systems on all their aircraft, had certified their weapons were functioning correctly, had watched them taxi out to the runway, engines roaring, propellers throwing back clouds of red dust from the mast and matting. Some came back, some didn't. The ones who came back told variations of the same story. Perfect setup, perfect shot, guns fired but didn't hit. Most of them thought it was their fault. Some blamed the gun sight calibration. A few wondered if the guns were misaligned. Sullivan knew the truth, but regulations prevented him from doing anything about it. Until the night, Lieutenant Chen came to the electrical shop and asked if there was any way at all, to make his guns fire like they were supposed to. Chen had just returned from a mission where he'd had 3 separate opportunities for kills. 3 times he'd maneuvered into position, gotten the target in his sights, squeezed the trigger. 3 times his fire had scattered. The last Zero had reversed on him so fast that Chen barely escaped. He'd come back to Nadzab with his hands shaking and his flight suit soaked with sweat. He found Sullivan in the maintenance area working on another P-38's generator system. The electrical shop smelled like solder flux and insulation compound. The evening air was thick with humidity and the sound of distant rain. Chen didn't waste time with pleasantries. He asked Sullivan directly if the guns on his airplane were broken. Sullivan explained they weren't broken. They were working exactly as designed, but the design had a flaw. Chen asked if the flaw could be fixed. Sullivan said yes, but it would require modifying the firing circuit in a way that violated every regulation in the Army Air Force's maintenance manual. Chen asked how long it would take. Sullivan said about 40 minutes if he worked alone, less if someone helped. Chen asked when Sullivan could do it. Sullivan told Chen to come back tomorrow morning. He'd see what he could do. Sullivan worked that night after the rest of the maintenance crew had gone to their tents. The electrical shop was lit by a single bare bulb hanging from a wire. Moths and beetles swarmed around the light, casting moving shadows across his workbench. Outside, the jungle hummed with insect sounds and the occasional rumble of thunder from storms building over the mountains. The modification Sullivan had in mind was simple in concept, but dangerous in execution. Instead of running the trigger signal through the distribution box to 5 separate relays, he would bypass the secondary relays entirely and wire all 5 gun solenoids directly to the main relay in parallel. 1 trigger pull, 1 electrical pulse, 1 relay activation, all 5 guns receiving power at exactly the same instant. No sequential firing, no delay, no cascade effect. The risk was that if the main relay failed, the pilot would lose all his weapons simultaneously instead of just one. But Sullivan had examined enough relay failures to know they almost always failed open, not closed. A failed relay would simply mean the guns wouldn't fire at all. The pilot would know immediately and could break off the engagement. That seemed like a better outcome than having guns that fired but didn't hit. The bigger risk was the electrical load. 5 gun solenoids drawing current simultaneously through a single relay designed for lower amperage. The relay might overheat, might weld its contacts shut, might catch fire. But Sullivan had run the calculations. The solenoids drew peak current only during the initial activation, maybe 1/10 of a second. The relay was rated for twice that amperage at continuous duty. Short bursts should be within tolerance. Should be. He wouldn't know for sure until someone actually fired the guns in combat. He pulled the wiring diagram for the P-38's weapon system from his technical library. The Schematic showed the distribution box mounted behind the instrument panel, just below the gun sight. Access required removing 3 inspection panels and disconnecting the control stick. 2 hours of work if you were careful. Sullivan gathered his tools: wire strippers, crimping pliers, solder iron, heat shrink tubing, and a dozen pre-cut lengths of 14-gauge aircraft wire. He walked across the dark airfield to Chen's assigned P-38, tail number 42783 Baker. The aircraft sat silent on the flight line, wings still warm from the day's sun. Sullivan unlocked the cockpit canopy, climbed into the left seat, and started removing panels. The space behind the instrument panel was cramped and hot. He had to work with a flashlight clenched between his teeth, hands wedged between fuel lines and control cables. Sweat dripped into his eyes. His knuckles scraped against sharp-edged brackets. The original wiring ran in neat bundles, secured with metal clips. Sullivan traced each wire from the distribution box back to its gun solenoid. 5 wires, 5 different colors, 5 separate circuits. He disconnected them one at a time, labeling each connection point with masking tape. Then he cut 5 new pieces of wire, stripped the ends, and crimped ring terminals onto each. Connected all 5 ring terminals to a single junction point at the main relay output. Used solder and heat shrink to ensure the connections wouldn't vibrate loose under combat stress. Routed the new wires through the existing cable bundles, tied them down with fresh safety wire, checked each connection twice. The modification took 38 minutes. When Sullivan finished, he sat in the cockpit testing the trigger circuit with a multimeter, measured the resistance from the control stick trigger to each gun solenoid. All 5 showed identical values within 0.03 ohms, perfect parallel circuit. He reassembled the panels, cleaned up his tools, and walked back to the electrical shop. His hands were shaking slightly, not from fear, but from the knowledge of what he'd just done. If the modification failed during flight, Chen would have no weapons. If it failed catastrophically, it might start an electrical fire. If anyone discovered the unauthorized change before Chen flew the mission, Sullivan would face court-martial. But if it worked, Chen might actually survive. Sullivan went to his tent, lay on his cot, and watched the ceiling until dawn. At 06:15, he walked to the flight line and watched the ground crew fuel Chen's aircraft, watched the armourers load ammunition belts into all 5 guns, watched Chen walk out from the briefing tent and climb into the cockpit. Chen gave Sullivan a slight nod through the canopy glass. Sullivan nodded back, said nothing. At 06:42, Chen started the engines. The twin Allisons coughed, fired, settled into a deep, synchronized rumble that shook the ground beneath Sullivan's feet. Chen taxied to the runway, ran, up the engines, released the brakes. The P-38 accelerated down the mast and matting, lifted off, climbed into the morning sky trailing twin plumes of exhaust. Sullivan stood on the flight line and watched the aircraft disappear into the clouds heading northwest toward Japanese-held territory. All he could do now was wait and hope the wiring held. The engagement began at 07:28. Chen's flight of 8 P-38 seconds intercepted a formation of 16 Zeros and 8 Oscars at 14,000 feet over the Huon Gulf. The Japanese were escorting a group of transport aircraft trying to resupply their garrison at Wewak. The morning sun was behind the American formation, giving them the advantage of surprise for the initial attack. Chen was flying number 5 position in the second element. His flight leader, Captain James Morgan, called out the bounce over the radio. The P-38 seconds rolled inverted and dove, building speed to 400 miles per hour. Chen selected a zero flying, tail-end position on the enemy formation. The target grew larger in his gun sight as he descended. He could see the painted Hinomaru on the fuselage, the canopy reflection, even the slight wobble in the Zero's flight path as the Japanese pilot made small corrections to stay in formation. Chen pressed his thumb down on the trigger button at 300 yards. What happened next felt completely different from every other time he'd fired his guns. There was no staggered hammering, no progressive build-up of sound. Instead, all 5 weapons detonated simultaneously. The noise was overwhelming, a single massive crack that shook the entire airframe. The recoil pushed back against the aircraft like someone had punched the nose. Through his gun sight, Chen saw something he'd never witnessed before. A solid cone of tracers reached out from his aircraft to the Zero, not scattered streams, not individual bullets walking across space, a unified, concentrated river of fire. The effect on the Zero was instantaneous. The 20mm cannon rounds hit first, punching through the fuselage just behind the cockpit. Then the 50 caliber rounds arrived, all four guns converging on the same impact point. The Zero's fuselage disintegrated, the tail section separated, the wings folded upward. Pieces of aircraft tumbled through the air, trailing smoke and flame. Chen's first burst lasted 0.8 seconds. The Zero was destroyed so completely that Chen actually flinched, surprised by the violence of it. He'd never seen that kind of destruction from his guns before. There was no time to process what had just happened. His wingman, Lieutenant David Park, called out Zeros, diving from above. Chen looked up and saw four of them coming down in a steep attack, trying to bounce the American formation during their climb back to altitude. Standard Japanese tactic. Let the Americans make their initial pass, then hit them when they were vulnerable and slow. Chen shoved his throttles to war, emergency power, and started a climbing turn to meet them. The lead Zero opened fire at long range, probably 500 yards. Chen could see the muzzle flashes from the wing-mounted guns. He waited, letting the range close, fighting every instinct that screamed at him to shoot back. At 250 yards, he centered the lead Zero in his gun sight and pressed the trigger. Again, that massive, simultaneous detonation. Again, the solid cone of tracers. The lead Zero flew directly into it. Chen held the trigger for 1 full second. Every round from all 5 guns hit the target. The Zero's engine cowling exploded. The propeller shattered. The cockpit canopy blew apart. The aircraft rolled inverted and fell away, trailing a stream of burning fuel. 2 kills in less than 90 seconds. Chen had doubled his career total. But the fight was far from over. The remaining 3 Zeros split, 2 breaking left, 1 breaking right. Chen followed the single Zero to the right, rolling his P-38 90 degrees and pulling hard. The Zero was faster in the turn, could outmaneuver the heavier American fighter easily. But Chen wasn't trying to turn with him. He was trying to predict where the Zero would be. The Japanese pilot did exactly what Chen expected, reversed his turn, trying to get behind the P-38. But Chen had already rolled out and was pulling lead. The Zero filled his gun sight. Chen fired. The concentrated burst hit the Zero's left wing root. The wing folded instantly. The aircraft tumbled out of control, breaking apart as it fell. 3 kills. Chen's head was spinning. He'd been in combat for maybe 2 minutes. Had fired his guns 3 times. 3 Japanese aircraft destroyed. His hands were shaking on the control stick, but not from fear. From adrenaline, from disbelief, from the sudden understanding that his airplane had just become exponentially more lethal. The engagement lasted another 4 minutes. Chen got separated from his element during the maneuvering, found himself alone at 12,000 feet with Zeros above and below him. One Oscar made the mistake of crossing in front of him at 300 yards range, probably didn't see Chen's P-38 against the cloud background. Chen fired a 1-second burst. The Oscar's tail came off. 4 kills. Chen was out of ammunition for his 20mm cannon, still had rounds for the 50 calibers. He climbed back toward friendly airspace, watching his fuel gauge drop toward minimum reserves. 2 Zeros tried to chase him, but couldn't catch the P-38 inches a straight line at full throttle. Chen landed at Nadzab at 0837. Sullivan was waiting on the flight line. He'd been standing there for nearly 2 hours, watching the sky, listening to the distant rumble of combat, wondering if Chen was alive or dead, wondering if the modification had worked or if it had killed him. When Chen's P-38 appeared in the landing pattern, Sullivan felt his chest tighten. The aircraft looked intact, no visible damage, both engines running smoothly. Chen touched down, rolled to his parking spot, shut down the engines. The propellers windmilled to a stop. Chen sat in the cockpit for a long moment before opening the canopy. His hands were still shaking when he climbed down the ladder. His flight suit was drenched with sweat. He walked straight to Sullivan, and before Sullivan could ask anything, Chen said 4 words. It worked. 4 kills. Sullivan felt something release inside his chest. Relief, vindication, terror at what he'd done, pride in what it had accomplished. All of it hit him at once. Chen explained what had happened: the simultaneous firing, the concentrated firepower, the devastating effect on targets. He said it felt like flying a completely different airplane, like someone had replaced his guns with something twice as powerful. What neither of them realized was that 5 other pilots in Chen's flight had watched the engagement from different altitudes. Captain Morgan had seen Chen destroy the first Zero from above. The violence of the kill was visible even from 3,000 feet away. The Zero hadn't just been damaged, it had been obliterated. Morgan had flown P-38 seconds for 8 months. He'd seen hundreds of gun camera films, watched dozens of live engagements. He'd never seen a single burst produce that kind of destruction. After landing, Morgan found Chen in the debriefing room. Chen was still amped on adrenaline, hands trembling as he filled out the combat report. 4 confirmed kills in 1 mission. Morgan asked him what was different. Chen said he didn't know. His guns just worked better today, fired harder, hit more accurately. Morgan asked if maintenance had done something to his aircraft. Chen said he should talk to Corporal James Sullivan. Morgan found Sullivan in the electrical shop 90 minutes later. Sullivan was working on a radio installation, his hands black with carbon residue from soldering. His coveralls were stained with hydraulic fluid and battery acid. Morgan asked him directly what he'd done to Chen's airplane. Sullivan looked at him for a long moment, weighing the consequences of honesty against the consequences of lying to a superior officer. Then he told him everything. The parallel wiring modification, the bypass of the distribution box, the unauthorized change to a weapon system. Morgan listened without interrupting. When Sullivan finished, Morgan asked if he could do the same modification to his own aircraft. Sullivan explained the risks. No engineering approval, no testing. If the relay failed, Morgan would lose all his weapons simultaneously. If the modification caused an electrical fire, both of them would face charges. Morgan said he didn't care. He'd lost 6 pilots from his flight in the past 2 months, all caught in situations where they'd had clear shots but couldn't make their guns converge. If there was something that could improve their chances, he wanted it. Regulations could wait until after they got home. That evening, Sullivan modified Morgan's P-38, same parallel wiring, same relay bypass, same installation procedure. Morgan flew it the next morning on a fighter sweep over Madang. He came back with 2 kills and a story about how his guns had fired like a single weapon instead of 5 separate ones. Told his wingman the firepower was incredible, overwhelming, more effective than anything he'd experienced in 8 months of combat. The wingman, Lieutenant Robert Hayes, found Sullivan that afternoon and asked if he could get the same modification. Sullivan said yes, but Hayes had to understand the risks. Hayes said every mission over Japanese-held territory was a risk. At least this risk came with better firepower. By November 28th, Sullivan had modified 12 aircraft. Word spread through the squadron faster than official communications ever could. Pilots talked in the ready room, comparing notes on their gun performance. Some noticed their squadron mates were getting more kills, coming back from missions with combat footage showing devastatingly effective fire. Others heard rumors about an electrical modification that made the guns fire simultaneously. Some crew chiefs refused to do the modification when their pilots asked. Said it violated regulations, could get them court-martialed, wasn't worth the risk. But other electricians were willing to try. Sullivan showed them how. Bypass the distribution box, run all 5 solenoids in parallel from the main relay, check the connections twice, test the circuit before flight. Takes 40 minutes if you work carefully. Changes everything. If you find this story engaging, Please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The modifications spread from pilot to pilot, mechanic to mechanic. No official documentation, no engineering approval, no paper trail. Just whispered. Conversations in the maintenance area and flight line. Chen got 3 more kills on December 2nd using the modified system. Morgan got 4 on December 7th. Hayes got 2 on December 10th. Other pilots started coming back from missions with their first kills after weeks of frustration. Lieutenant Frank Wilson had flown 21 missions without a single victory. He'd had opportunities, dozens of them, good setups, clear shots, but his guns had never seemed to hit where he aimed. After getting the modification on December 5th, Wilson shot down 2 Zeros on his very next mission. He described it as the difference between throwing individual punches and swinging a sledgehammer. The concentrated firepower didn't just damage enemy aircraft, it destroyed them. The statistics became impossible to ignore. In October, before the modification, the squadron's kill-to-loss ratio was 0.73 to 1. American pilots were being shot down faster than they were shooting down Japanese aircraft. In November, the ratio improved to 1.1 to 1, roughly even. By mid-December, with nearly 30 aircraft running the modified firing system, the ratio had climbed to 2.4 to 1. The squadron engineering officer, Captain Barnes, noticed something had changed but couldn't identify what. He ordered inspections of the gun systems on several aircraft. The electricians who'd done the modifications simply rewired the circuits back to factory standard before the inspections, then reinstalled the parallel wiring afterward. Barnes saw standard wiring configurations, signed off the inspections, never discovered the truth. The pilots knew, the mechanics knew, nobody told the officers. The kill ratio kept climbing. Then the Japanese noticed. Japanese fighter pilots first reported the change in early December. Combat reports from the 4th Air Army mentioned that American P-38 seconds were demonstrating significantly more effective firepower. Pilots who had survived encounters with lightnings in previous months noted that the weapons seemed more concentrated, more destructive. Lieutenant Izumu Sasaki was a Zero pilot with 18 confirmed victories. He'd been fighting American aircraft since Guadalcanal. On December 12, 1943, Sasaki engaged a P-38 over Alexishafen. He used his standard tactic, waited for the American to open fire, then maneuvered through the gaps in the scattered fire pattern. Except there were no gaps. Sasaki saw the P-38's nose light up with muzzle flashes, expected to see individual tracer streams that he could dodge between. Instead, he saw a solid wall of fire coming directly at him. He threw his Zero into a maximum G turn, felt the airframe groan under the stress, barely avoided the burst. Sasaki had been in combat for 2 years. He knew what P-38 fire looked like. This wasn't normal. The concentration was too tight, the destructive effect too immediate. 2 other Zeros in his formation weren't as lucky. Both were hit by single bursts. Both disintegrated in mid-air. Sasaki returned to his base, shaken, filed a report describing the engagement, noted that American P-38 weapon systems appeared to have been modified or upgraded. The guns no longer fired in sequence but simultaneously, creating a concentration of fire that was nearly impossible to evade. Other experienced Japanese pilots reported similar encounters. P-38 seconds that had been predictable opponents were suddenly devastating. The Americans weren't using different tactics. They weren't flying better or faster. But their weapons had changed, and Japanese pilots were dying because of it. Japanese intelligence tried to determine what had been modified. They examined wreckage from downed P-38 seconds, looking for new weapons or upgraded gun systems. Found nothing. The aircraft appeared identical to the ones they'd been fighting for months. Same guns, same ammunition, same mounting points. What they didn't know was that the propulsion change was hidden inside the fuselage, a rewired circuit that looked almost identical to the original configuration. Even if Japanese engineers had captured an intact P-38 with the modification, they might not have understood its significance. It wasn't a new weapon. It wasn't advanced technology, just a different way of connecting 5 wires to a relay. But that simple change was killing Japanese pilots at rates they hadn't experienced since the early days of the war. The psychological impact was significant. For 18 months, Japanese pilots had learned to predict P-38 firing patterns. They knew the guns fired in sequence, knew how to time their evasive maneuvers to slip between the streams of fire. That knowledge had kept them alive through dozens of encounters. Now that knowledge was obsolete. Pilots who had survived by understanding their enemy's weapons were getting shot down because the weapons no longer behaved predictably. Some Japanese pilots adapted by avoiding P-38 seconds entirely unless they had significant numerical advantage. Others tried to compensate by being more aggressive, closing to shorter range before engaging. But aggression, without the ability to predict enemy fire, just meant dying faster. By the end of December, the 4th Air Army had lost 62 fighters in combat with P-38 seconds. American losses in the same period were 26 aircraft. The kill ratio had reversed dramatically. For the first time in the Southwest Pacific Theater, P-38 seconds were destroying Japanese fighters at nearly 3-to-1 rates. Japanese commanders began issuing tactical guidance to avoid engaging P-38 Lightnings unless absolutely necessary. That guidance marked a turning point. The P-38 had gone from a capable but flawed fighter to something Japanese pilots actively feared. And it was all because of a wiring modification that nobody was supposed to install. The modification remained unofficial throughout the war. The Army Air Force's Engineering Command learned about it in January 1944, when an electrical inspector at Dobodura noticed inconsistent relay configurations during a routine maintenance audit. He traced the discrepancies to the parallel wiring modifications, wrote a detailed report, and sent it through channels to 5th Air Force headquarters. The report sat in various offices for 5 weeks, while officers debated what to do. The modification clearly violated regulations. Field electricians had no authority to alter weapon system wiring, but the modification was also clearly working. Squadrons using it had measurably higher kill ratios and lower loss rates. The question wasn't whether the modification helped. The question was whether to punish the electricians who'd installed it without authorization or quietly approve it after the fact. In March 1944, Lockheed sent an engineering team to New Guinea to evaluate the modification. They tested it on the ground, measured the electrical loads, calculated the stress on the relay systems, ran live fire tests. Their conclusion was that the modification was electrically sound and tactically effective. The increased amperage load on the main relay was within acceptable limits for short-duration firing. The elimination of the sequential firing delay significantly improved weapon effectiveness. Lockheed recommended integrating a similar parallel firing circuit into production P-38 seconds. The modification was incorporated into the P-38J25 model that entered production in June 1944. The factory installation used a heavy-duty relay, specifically rated for the higher amperage load, and included additional circuit protection. But the fundamental concept was identical to what Sullivan had jury-rigged in a maintenance tent in New Guinea. Sullivan never received official credit. No commendation, no medal, no mention in any technical report. The official Lockheed documentation attributed the firing system improvement to engineering analysis, field testing. Sullivan's name appeared nowhere. Chen survived the war. He flew 78 combat missions, shot down 19 Japanese aircraft, returned to California in 1945. He became an electrical engineer, worked for Douglas Aircraft, designed flight control systems for commercial jets. Every year, on November 23rd, Chen called Sullivan to thank him for the modification that had saved his life and made him an ace. Sullivan stayed in the Army Air Forces after the war, eventually retiring as a master sergeant in 1963. He worked as an industrial electrician in Nevada until 1985, never spoke publicly about the P-38 modification, never sought recognition for what he'd done. When he died in 1997, his obituary mentioned his military service as an aircraft electrician in World War II. It did not mention the wiring modification, Did not mention that he'd changed how American fighters delivered firepower. Did not mention that he'd broken regulations to save lives. But in Chen's garage in San Jose, there's a photograph on the wall. A young electrician in grease-stained coveralls standing beside a P-38 Lightning. On the back, written in faded ink, is a note. November 1943, Nadzab. The man who made my guns work. R.C. Below that, in different handwriting, probably added years later, is a single sentence. 40 minutes of illegal wiring, 19 kills. A life saved. The modification spread beyond Sullivan's squadron. By the end of the war, electricians across the Pacific Theatre were installing the parallel firing circuit in P-38 seconds. Some learned about it from transferred personnel. Others figured it out independently after hearing descriptions of the improved firepower. The modification was never officially acknowledged, but it became standard practice in field maintenance. When post-war researchers analysed P-38 combat effectiveness, they noted a significant improvement in kill ratios starting in late 1943. Most attributed this to better pilot training, improved tactics, or declining Japanese pilot quality. Few recognized that a substantial portion of the improvement came from a simple wiring change that made 5 weapons fire as one. The lesson was buried in classified maintenance records and forgotten technical reports. But it remained valid. Sometimes the difference between victory and defeat isn't in the design of the weapon, it's in how you connect the wires. Sometimes the solution to a complex problem isn't a new technology or advanced engineering. It's a field electrician with a soldering iron and the willingness to break regulations to save lives. Sullivan understood that instinct better than any officer or engineer. He didn't wait for approval or permission. He didn't submit requests through proper channels. He saw a problem that was killing pilots, knew how to fix it, and did the work himself in the darkness of a maintenance tent, with nothing but a flashlight and a wire diagram. The parallel firing modification was simple, almost embarrassingly so. 5 wires connected to one point instead of 5 separate points. 40 minutes of work. No exotic materials, no complex calculations, no breakthrough science, just basic electrical knowledge applied with precision and courage. Yet that simple change transformed the P-38 Lightning from a fighter that struggled to hit targets into one that destroyed them with devastating efficiency. The modification's effectiveness came from understanding that firepower isn't just about the number of guns. It's about when those guns deliver their energy. 5 guns firing in sequence over 0.27 seconds spread their damage across time and space. 5 guns firing simultaneously concentrate that same energy into a single instant. The difference is exponential. A Zero could maneuver through sequential fire, exploiting the gaps between individual weapons. But against simultaneous fire, there was no gap to exploit. The entire cone of destruction arrived at once, overwhelming the target's structure before it could react. This principle would later influence weapons design across multiple generations of combat aircraft. The concept of synchronized, concentrated firepower became standard in fighter design. Modern fighters use computer-controlled firing systems to ensure all weapons discharge simultaneously with microsecond precision. The technology is sophisticated, but the principle remains identical to what Sullivan implemented, with simple parallel wiring in 1943. History often celebrates the inventors and engineers whose names appear on patents and technical papers. But wars are won by the mechanics and technicians who take those designs and make them work in the field, who identify the flaws that laboratory testing missed, who improvise solutions with whatever materials they have available. Sullivan was one of those invisible contributors. His modifications saved lives, changed tactical outcomes, influenced future designs. But his contribution exists only in fading photographs, scattered memories, and the statistical evidence of improved kill ratios that nobody connected to a wiring change. The pilots who flew with the modification knew. They felt the difference every time they pressed the trigger and felt their aircraft shudder from the concentrated recoil. They saw the difference in their gun camera footage, watched enemy aircraft disintegrate under fire that finally hit with the full force it was designed to deliver. For them, the modification wasn't theoretical or technical. It was survival. It was the difference between coming home and becoming another name on a casualty list. It was the reason they could fight with confidence instead of doubt, knowing their weapons would deliver when they needed them most. And somewhere in the chain of events that led from Sullivan's workbench to the sky over Guinea, there was a moment when theory became reality, when an unauthorized modification became the difference between life and death, when breaking the rules became the right thing to do. That moment happened at 07:28 on November 23, 1943, when Lieutenant Robert Chen pressed his trigger and felt all 5 guns fire as one for the first time. Everything changed in that instant. Not just for Chen, but for every pilot who would fly with the modification, every Japanese pilot who would face it, every future engineer who would build on the principle it demonstrated. Sullivan never claimed to have changed history. He was just an electrician trying to help his pilots survive. But in the anonymous machinery of war, small actions can create cascading effects. A single modification, repeated across dozens of aircraft, can shift the balance of entire campaigns. A moment of courage, choosing to act despite regulations, can save hundreds of lives. The story of the P-38 parallel firing modification is the story of how wars are actually won, not through grand strategies or advanced technology alone, but through the accumulated efforts of individuals who see problems, understand solutions, and possess the courage to act. Sullivan saw a problem in the wiring, understood the solution in parallel circuitry, had the courage to implement it without authorization. That combination of technical knowledge and moral conviction made the difference. The modification worked because Sullivan understood both the technology and the stakes. He wasn't just connecting wires. He was giving pilots a chance to survive. Every connection he made was precise because he knew lives depended on it. Every test he ran was thorough because failure meant death. That level of care, that sense of personal responsibility, cannot be mandated by regulations or enforced by supervision. It comes from within, from understanding that your work has consequences beyond the immediate task. Sullivan embodied that understanding. His legacy isn't in official records or technical manuals. It's in the lives he saved through work that nobody was supposed to notice. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.